Right, let's just have a quick look at the memo for weekly test 2 for my 214 course. Overall, you guys were doing fine. Just keep making sure that you know your solvents. That's THF. Almost all of you got that done pretty well. But that stands for tetrahydrofuran. A lot of you had things like fluorine and some other funny things going over here, but this is the structure tetrahydrofuran, a cyclic ether, very common solvent. This one a lot of you got wrong. I'm surprised because I mentioned it in class before we even wrote the test. This is a reduction with sodium borohydride, and the solvent that we need is an alcohol. A typical one would have been methanol, but at this stage I would have accepted if you'd done any other alcohol or water would have been okay. So we'll go through the marks over there. In terms of this question over here, this is a bit far away, but a nucleophile reacts with its HOMO, its highest occupied molecular orbitals, because a nucleophile has electrons to give, and the most important thing is that a nucleophile prefers the HOMO to be high in energy. This is a good overlap for nucleophile electrophile reactions. It's a high energy HOMO that reacts that way. And then lastly was the molecular orbital diagram that I wanted you to draw, or at least to draw in the orbitals. Whenever we work with a nucleophilic addition to a carbonyl, it's always the pi star, and so we draw the pi star orbitals in, something like that, and then we shade in. It doesn't matter if it's which way around it was, but something along those lines. So that's the pi star, so we should write that pi star, and it's also the LUMO that we are looking at, the lowest unoccupied molecular orbital. And then the nucleophile, your carbon-metal bond, remember it's the actual sigma bond that is reacting. This line that we've drawn over there, what I gave to you, is where the electrons are. It's this sigma bond there, sigma orbital, which is the highest occupied molecular orbital, and that's the one that has the electrons in it, and those are going to add to the empty LUMO orbital of the carbonyl. And that's kind of like the picture that I was expecting you to do. And it doesn't matter what nucleophile we use, but it's always going to be that very similar pattern and shape. Lastly, the bonus question over here was, what is this angle of attack? Remember, I said I don't expect you to know it, but I'll give it as a bonus question sometimes. So the first time you've sent it as a bonus question, it's 107. You actually all did that very well. And for those of you really space cadets out there, it's the Berge-Dunitz angle. But I didn't actually ask that there, so it's not even part of it. But that's the name of that. All right. I hope that was helpful to you guys.